Good afternoon, folks. It gives me a great deal of pleasure to introduce our speaker today, and I'll get to that shortly. But since we have a lot of non-Cartmelians in the Zoom audience today, I want to provide a brief background as to why Cartmel is hosting this great event. In the year 2018, Cartmel's Long Range Landscape and Natural Resources Planning Committee recommended that we have at least one educational event a year. And so this year we are so fortunate to be able to host Dr. Douglas Tallamy, an internationally known scientist, teacher, speaker, and book author. Doug has excelled in teaching, mentoring, advising, and clearly impacting the lives of the students, plus the countless thousands of people who have attended his seminars like today and who have read his books. And I know many of you in the audience have read at least one of his books because I've heard you say that. Doug's research is also outstanding and genuinely reflective of a world-class scientist. He's published widely in professional journals in addition to the Scientific American. His research has focused on the interactive or the interface between the plant and animal worlds. But perhaps the hallmark of his scholarship is in his books. In 2009, he authored Bringing Nature Home. 2014, he co-authored The Living Landscape with Rick Dark, who was a broadly knowledgeable botanist and horticulturist and a graduate of the University of Delaware and one of my former students. In 2020, Doug's latest work, Nature's Best Hope, and you may hear those three words a little bit later in Doug's presentation, but in Nature's Best Hope, that achieved the 15th ranking on the New York Times bestseller list in 2020. Just this past month, in January 2021, Doug was named the T.A. Baker Professor of Agriculture and Natural Resources because of such a superb background that he has. And because of that, you can see why I think we are so fortunate to be able to get Dr. Tallamy as our speaker today. His topic that I have given him is how can the residents of Cartmel preserve and improve our environment, both in the short term and the long term. Since the audience is mute and they cannot help me welcome you, Doug, with their applause, I will applaud you by introducing you now and say you are on. One last thing before Doug speaks. Let's keep all of the questions until after the presentation, and we suggest that you add them to the chat box so we can pick them up later. Okay, Doug, you're on.
Well, thank you very much, Jim. That was quite an introduction. I'm screen sharing here. Okay, a shortened version of Jim's title is to talk about why the people of Cartmel and anybody else who's listening are in fact nature's best hope, because of the way I hope we can all start treating our local landscapes. But before we talk about any of that, I want to go back to what happened not this fall, but the previous fall, a year ago. Up and down the East Coast, we had what is known as an oak mast. All the members of the red oak group got together and produced their acorns at the same time. And this is what it looked like in a lot of places. Well, I am easily entertained. So I took one of those acorns and I just stared at it. And I was rewarded because an insect started to chew its way out of the acorn. First it chewed a hole, forced its head through the hole, and then forced the rest of its body through the hole. It was a tight squeeze, made it look like the Pillsbury Doughboy. Finally plopped down. This is a very dangerous time for this insect larva because it is so good to eat. Lots of things are after it. So it squirms and wiggles and gets beneath the soil in about 30 seconds, where it stretches in all directions and makes a chamber. And within that chamber converts itself to a pupa, and it stays in that chamber as a pupa for 2 years. Then it comes out and is an acorn weevil. This is what an acorn weevil looks like. A lot of people think weevils have big noses, but in fact, that's an extension of the head capsule, and the mouth parts are way down at the end of that extension. And they take those mouth parts and chew a hole into the center of the acorn, then turn around and lay an egg on it. And that is how the egg gets, that's how the larva gets into the center of the acorn. Now you might wonder why they spend 2 years underground. Why don't they come out the next year as most insects would? And the answer is that it takes red oak acorns 18 months to complete their development. And if they came out the very next year, there wouldn't be enough acorns for them. Well, that of course leaves a hole in the acorn. And that is a true vacuum. You know that nature abhors a vacuum. And in this case, she has filled it with 3 species of temnothorax ants, tiny little red ants whose entire colony lives inside the vacated holes made by acorn weevils in acorns. Well, their acorns don't last forever. So whenever they find a brand new one, they get excited and they want to move the entire colony into it. So first they communicate, we've got a new acorn. And then everybody gets busy. They grab the larvae and the eggs and the queen and they carry them all in. That takes about 30 minutes. But then they post a guard at the entrance here, make sure nobody else comes in. And that's where they'll live for the next 2 years. Well, about this time, my wife, Cindy, says, what is your point? What are you trying to tell us? What I'm trying to tell you is that is just one of literally millions of very specialized interactions between animals and plants. And that is what nature is comprised of for the most part. This is another specialized interaction, the interaction between jays, blue jays in this case, and oaks. Blue jays are the primary disperser of oak acorns. They'll take an acorn from the tree, then they fly up to 2 miles from that tree, tap the acorn beneath the ground. The idea is to go get it again during the wintertime so they have something to eat, but they don't have a perfect memory and they forget where they buried a lot of acorns. And a single jay can actually end up planting over 1,000 oak trees every single year. You won't have pileated woodpeckers anywhere near you if you don't have a lot of carpenter ants, because carpenter ants are what they feed their young. That's how they rear their young. And you won't have carpenter ants unless you have the big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have this plant, Facilia. That is the only pollen that particular bee can rear its young on. That's pollen specialization. And it turns out that pollen specialization is very common in our native bees. We have over 4,000 species of native bees, and over a third of them specialize. They only reproduce on the pollen of particular plant genera. So for example, in this area, there are 13 species of bees that can only reproduce if they have the pollen of perennial sunflowers. You won't have Baltimore checker spots unless you have white turtlehead, and on and on and on. Nature really is a series of specialized relationships. The problem is that today, these relationships, nature itself is on the ropes. And it's on the ropes because we did not take Teddy Roosevelt's advice. Way back in 1908, the state of Arizona was going to mine the Grand Canyon, and Teddy heard about that. So he went to the canyon and he stood on the edge, looked out and said, leave it as it is. And with those 5 words, he started the process of creating the Grand Canyon National Park. The problem, of course, is that today we don't have the option of leaving most of the country as it was, because we haven't. There's only about 5% of the lower 48 states that's anything close to its original pristine ecological condition. And that's because we have logged the country repeatedly, we have tilled it, we have drained it, we've grazed it. We have 770 million acres of rangeland in the US, which is 4.5 times the size of Texas. And of course, we paved it or otherwise developed it. We straightened our rivers and dammed them, and you can spell that any way you want. We have polluted our skies and changed our climate for centuries to come. We have drained our aquifers. We have introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas. In short, we have carved up the natural world into tiny remnants of its former self. And each one of those remnants is too small and too isolated from other remnants to sustain the species that run the ecosystems that we all depend on. Why have we done this? Well, I imagine we thought the Earth, our nest, was so large that we could foul it forever and there wouldn't be any consequences. But of course, we were wrong about that. And that's why we're seeing headlines like this, very distressing headlines. The insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. Followed by this one, North America has lost 3 billion birds in the last 50 years. That's 1/3 of the North American bird population gone. Followed by this unhappy headline. The UN now predicts we will lose 1 million species to extinction, possibly in the next 20 years. And I love the way they report it as if it's an option. I mean, they might as well say we're going to lose oxygen in the next 20 years and go on to the next headline. Losing a million species is not an option, folks. We have to do something to make sure that doesn't happen. So I could go on talking about the pox that we humans have delivered upon the environment, thus upon all of our houses. But that's not what this talk is about. This talk is about a cure for that pox. And it's a cure that will take small efforts from lots of people. But those efforts will deliver enormous physical, psychological, and environmental benefits to everybody. Let's return to this headline. The insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about that global insect decline. Well, Edward Wilson, E.O. Wilson from Harvard, probably the most famous biologist, certainly the most famous entomologist alive today. He's 92. He still writes a book every year. He told us what it would mean if we lost insects. And he did it way back in 1987 with this paper, The Little Things That Run the World. And his message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of the flowering plants that are out there. They would disappear as well. And that would so drastically change energy flow through our terrestrial ecosystems that the food webs that support our animals, our amphibians, our reptiles, our birds, our mammals, even many of our freshwater fish, those food webs would collapse and most of those organisms would disappear. The biosphere, the living portion of the earth, would rot because we would have lost insect decomposers that right now rapidly turn over nutrients. All we would have is bacteria and fungi. And of course, humans would not survive any of those drastic changes. The good news is none of that has to happen. We can save our insects, we can save our birds, we can save nature itself, and thus ourselves. But we're going to have to change the way we landscape in order to do it. Why is that? Well, let me just remind you that humans are products of nature. We are totally dependent on nature. We're totally dependent on healthy functioning ecosystems that produce what we call ecosystem services. Here are some of the things that plants deliver for us, like oxygen, pretty important. Plants also clean water and they slow its journey to the sea where it's too salty to use. Carbon capture, enormously important today. It's plants that are pulling carbon dioxide out of the atmosphere, using the carbon in that molecule to build their tissues, but then they pump the extra carbon through their roots into the ground, where it can stay for tens of thousands of years out of harm's way. The soil around you is brown or black because of carbon that plants have put in the ground over the eons. They build topsoil and hold it in place. They prevent floods. They dampen severe weather. Lots of important things. What do animals do for plants? Well, they provide pest control services. They pollinate nearly 90% of those flowering plants. They disperse plant seeds and other things as well. So designing landscapes like this that destroy the production of ecosystem services is simply not a good idea today. We have 7.8, 7.9 billion people on the planet. We need more ecosystem services today than ever before. So creating huge deadscapes on the planet is just not an option. There were visionaries through the ages who understood that we humans needed to work on our relationship with planet Earth. And Aldo Leopold was certainly one of the most eloquent. He wrote extensively in the first half of the 1900s. And one of the things he said is the oldest task in human history is to live in a piece of land without spoiling it. Now, there have been some indigenous groups that have been good at doing that, but by and large, our huge Western societies and our huge Asian societies are terrible at living on a piece of land without spoiling it. We habitually take more from the earth than the earth has to offer, completely spoiling an area, then we move to another place and do the same thing. Well, Aldo recognized that was not a sustainable relationship with the planet. So he had a dream that we humans were actually capable of developing what he called a land ethic. He knew that we had to use the earth. We had to farm it and lumber it and graze and mine and do all the things we do. But if we exhibited a land ethic, we would learn to do those things we'd do them gently. We'd do them without destroying local ecosystems. And he wrote about the land ethic in the Sand County Almanac, his most famous book. What he never talked about, though, was creating a land ethic where we actually lived. And I'm not sure why that was, but I suspect that the notion that humans and nature cannot coexist in the same place at the same time, that notion was so deeply embedded in the culture of Aldo Leopold's day that he didn't even recognize it as an option. And of course, that notion is embedded in our own culture today. But what I'm going to argue this afternoon is that living with nature not only is an option, it is now the only viable option that is left to us. In the past, conservationists worked exclusively, pretty much exclusively, where there weren't a lot of people. We now need to turn that on its head. We need to save nature, actually put it back together again, recreate it where there are a lot of people, because that's most places. In other words, we have to find ways for nature to thrive in human-dominated landscapes. We're not going to get rid of human-dominated landscapes, so we need to find ways for nature to thrive. And I mean thrive. I don't mean just hang on. Where are we going to do that? Let's go back to private property. 85.6% of the US east of the Mississippi is privately owned. If we only do conservation on public lands and ignore private property, we're going to fail, because then we're not working with enough area. We need to do conservation pretty much everywhere if we're going to succeed. Now, when I talk about conservation, I'm really talking about a form of restoration. We need to rebuild natural systems where we've already dismantled them. So to do that, we have to start with the most important species. Not all species contribute to ecosystem function equally. So we have to start with the species that other species depend on. And there are two groups that we need to focus on. We talked about how important those flowering plants were. Well, you're not going to have flowering plants unless you have the pollinators that keep those flowering plants reproducing so that they continue on each generation. So we need the plants and the bees, but we also need to get the energy that those plants capture from the sun and turn into food, which is now stored in their leaves. We have to get that food to other animals. Most vertebrates do not eat plants directly. They eat something that ate plants. That something typically is insects, but it turns out that caterpillars are transferring more energy from plants to other animals than any other type of plant eater. So if you want to have a viable food web with other living things around you, you have to have a landscape that supports a lot of caterpillars. Otherwise, most of the energy remains locked up in plant leaves, and you have a failed food web. Let's use the Carolina chickadee as an example. That's the species of chickadee we have right here. Chickadees, during the wintertime, go to our feeders all the time. We think that's what they need is seed, and they do, but only 50% of their diet during the winter is seed. The other 50% is insects, believe it or not. But when they're reproducing, their babies can't eat seeds at all. So they become 100% insectivores. They will feed their young insects, but if they're in a healthy environment, they'll feed their young exclusively on caterpillars. And they are not exceptions. 96% of our terrestrial birds rear their young on insects, and most of those insects are caterpillars. How do I know that? There's a number of studies that suggest that, but this is a citizen science project that one of my grad students finished recently, Ashley Kennedy. She put out a call for bird photographers to take pictures of birds when they were bringing food to the nest and send those pictures to Ashley, and then she would identify the prey items that are in the beak. The object was to reconstruct the nestling diet of as many birds as she could in North America. And she got thousands of pictures. So she had enough data to reconstruct the nestling diet of 20 of the common bird families. The green bars that you're seeing here are the percentage of each one of those nestling diets that was caterpillars. And in 16 out of the 20 common bird families, caterpillars dominated the diet. So again, imagine what would happen if we took caterpillars out of our landscapes. Most of the birds would not be able to reproduce successfully. So something special about caterpillars, let's talk about what it might be. There's actually several things special about caterpillars, and one of them is that they are relatively soft. Think of this guy as if he is a little sausage with a very thin wrapper. The thin wrapper is exoskeleton, it's cuticle made of chitin, which is undigestible. The birds don't want a lot of that. And because caterpillars are soft, you can stuff them down the throat of your baby without fear of injuring the esophagus. And if you've ever watched a parent bird feed their young, they're pretty rough. They take their beak and it's like a plunger. They just stuff it down there. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass, the weight of 200 aphids. Now, some of our smaller birds do chase aphids around, but do you want to chase 200 aphids or get one caterpillar? They're nutritious. They're very high in fat, very high in protein, have a low percentage of chitin, of exoskeleton, compared to many other types of insects, particularly beetles. Beetles are not like little sausages. They're like little tanks. Most of a beetle is undigestible, and they also have a lot of sharp edges. Finally, caterpillars are very high in carotenoids. They are the best source of carotenoids for birds during the breeding season. Now, I mentioned carotenoids not because I love organic chemistry, but because I'm a vertebrate and you're a vertebrate and birds are vertebrates, and vertebrates cannot make their own carotenoids. We have to get them from plants, and we have to get them from plants because they are essential components of vertebrate diets. And that's why my wife Cindy makes sure that I eat a lot of carrots to get my beta carotene. I eat a lot of tomatoes to get my lycopene, a lot of whatever that is to get my lutein. And when she succeeds in getting me to eat those things, it improves my immune system. And I can't think of a better time to have a very strong immune system. Carotenoids are also antioxidants. They run around our body, protect our DNA from oxidative damage. That's very important. They improve color vision. When your mother said, eat your carrots, you will see better, she was right. She didn't know she was right, but it turns out she was right. They improve sperm vitality, improve sexual attractiveness. Now we're talking about things like this prothonotary warbler, male, who has had access to lots of luteins. And he takes those luteins and makes pigments out of them and puts them in his feathers. And that is why he is bright yellow. And the brighter yellow he is, the more ladies he attracts. Well, where are they getting their carotenoids from? From, of course, the prey items that they bring back to the nest, but carotenoid levels in bird prey items are not equally distributed. The first two bars here are types of caterpillars. They have far more carotenoids than other types of insects. The third bar is orthopteroids, things like grasshoppers, crickets, katydids. Here are the adult caterpillars down here, the moths and butterflies themselves. They have far fewer carotenoids because they're not eating green leaves. It's the caterpillars that eat green leaves. And here's the earthworm way down here. So the early bird gets the worm, but he doesn't get any carotenoids. So it's really looking like the caterpillars are not optional parts of bird diets. It's looking like caterpillars are essential parts of bird diet. So let's just say birds need caterpillars. The next question is, how many caterpillars do they need? Is one or two enough, or one or two a day enough? Well, let's go back to chickadees. We have a lot of data from chickadees, and ask the question, how many caterpillars does it take to make a nest of chickadees? One or two a day is not enough. It takes thousands of caterpillars for one clutch of chickadees just to reach the point where they leave the nest. 6,000 to 9,000 caterpillars, depending on the number of chicks in the nest. And after they leave the nest, the parents continue to feed them caterpillars for another 21 days. But they're flying all around, so nobody's able to count those. So thousands and thousands of caterpillars. And if we want chickadees to breed in our yards or on our campuses, and we do, because that's what's out there, there are very few natural areas, then we need to have all those caterpillars right there. Chickadees are not flying 5 miles down the road to the nearest woodlot. They forage about 50 meters from the nest. And if we landscape in a way that does not create all those caterpillars, that's called insect decline. And there's a growing evidence that insect decline is one of the major factors causing bird declines. How do we know that? Well, we went to the data from Rosenberg et al., the paper that said we've lost 3 billion birds, went to the original data set and divided the bird species up into the species that required insects at some part of their life history, usually when they're breeding, and the bird species that don't require insects, things like doves and finches that can actually reproduce on the seeds that they get. Those groups, the ones that don't require insects, actually gained a little bit in the last 50 years, but the birds that require insects lost on average 10 million individuals per species in the last 50 years. This doesn't prove cause and effect between insect declines and bird declines, but it certainly is suggestive. So I think we need to seriously think about landscaping in a way that provides the caterpillars that not just birds, but many other things require, or we're going to lose all of those species. And that is a totally different way than we've thought about landscaping in the past. In the past, we thought about landscaping just in terms of aesthetic values. We want to create pretty landscapes. And if plants are just decorations, anything that eats them would mar the decoration, or at least we thought it would. So we didn't want anything out there eating our plants. We just wanted pretty plants. Well, if we decide that we do want caterpillars in our landscapes, how would you add them? You add the plants that support those caterpillars. There is a catch, though, and that is most plants don't support a lot of caterpillars. So we have to be fussy about which plants we choose for our landscapes if we want to support the birds and other living things. And the monarch butterfly illustrates this perfectly. We can have all of the crepe myrtles and all of the Bradford pears and all of the boxwoods and all of the burning bushes and barberries and all the other Asian ornamental plants that we put in our landscapes all the time, and not support a single monarch butterfly because they're fussy about what they eat. They only eat milkweeds. And if you don't have milkweeds, you don't have monarchs. And monarchs are an exception. Most of the insects that eat plants are what we call host plant specialists. They only eat particular plants. Why is that? Well, plants have made them very fussy. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants of the world. And that's why it's green out there in the summertime. It's not because there are no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. But we do know that insects eat plants. So how do they do that? How do they get around those chemical defenses? Well, this is where the specialization comes in. 90% of the insects that eat plants can only eat particular types of plants. There's all those plant lineages out there, but each one of them protects itself with a particular cocktail of chemical defenses. A species of insect cannot adapt to all of those different cocktails. So they pick one or two that are very similar, and they develop the enzymes that store and excrete and detoxify those compounds. They develop the behavioral adaptations and life history adaptations that minimize their exposure to those compounds. That takes a long period of evolutionary history with those plants for all those adaptations to fall into place. But once they do, then the insect can eat the plant. That's why monarchs can eat milkweeds. Milkweeds are toxic plants, but monarchs have adapted to them. But because they're adapting to milkweeds, they didn't adapt to anything else. So monarchs are locked into eating milkweeds. And that's what host plant specialization is. When you specialize in one group of plants, you can't eat anything else. And that is why when we bring in plants from other continents, most of our insects cannot eat them. All I'm trying to say here is that plant choice matters. If we're trying to develop landscapes that support other living things, we have to have insects that eat those plants, or it's not going to work. And in order to have that, you've got to choose the right plants. And I'm going to give you 3 examples of how well that works, starting with our house right here in Oxford, Pennsylvania. I'm sitting in this window right here. This is what it looked like when we moved in. We bought 10 acres on a farm that was broken up. It was a very old farm that had been farmed for 300 years before it was broken up. And it was exhausted. Most of the topsoil was in a valley over here. And the last thing they did before they broke up the farm was to mow it for hay. Well, in most of our natural areas here, or even our farmlands, when you're mowing hay, you're really mowing the rootstocks of all the invasive species from Asia. You're mowing multiflora rose and oriental bittersweet and Japanese honeysuckle and autumn olive and many others. And then you call that hay. So when we started to build the house, of course, they stopped mowing and all that stuff grew back. And that's what the 10 acres looked like. It was just this giant tangle of vines. Reminded us of Sleeping Beauty's castle. That's my wife, Cindy. She's getting ready to remove all these things, which just proves it's possible. Most of us, if we own property, do have a problem with invasive species, and it's very easy to throw up your hands and give up. But persistence, it does take a lot of work. There's no doubt about it. But if Cindy can do it, we all can do it. What was I doing when she was clearing the 10 acres? I was telling her she was doing a great job, but I also was putting plants back. And I was experimenting. I wanted to see that if I introduced the host plant, a particular species of caterpillars, would they actually come to our property? So I started, one of the first ones I started with was called the Canadian owlet. I'd never even seen a Canadian owlet. That's what the caterpillar looks like. That's what the adult looks like, just like a leaf. Well, Canadian owlets are host plant specialists on meadow rue. If you don't have meadow rue, you don't have Canadian owlets. Of course, we had no meadow rue, though the area had been farmed to death. So I got some meadow rue seeds from someplace, planted them. They grew very well, but I thought it would probably be years before Canadian owlets found my little patch of meadow rue. So I didn't go out and check it after I planted it until about a month and a half later. And I walked by and there it was almost defoliated by Canadian owlets. So that had worked really well. The Canadian owlets came right away. Now I have a good population of meadow and Canadian owlets. So I've added 2 species of biodiversity to our property. Same thing with the goldenrod stowaway. That's a misnomer. This beautiful yellow-orange moth has nothing to do with goldenrod. It's a specialist on this plant, Biden's aristosa. Some people call it ditch daisy. I did know where there was some ditch daisy in a power line cut about 14 miles away in Bear, Delaware. So I went and got some seeds, planted them. They grew very nicely, but it took about a year for that moth to actually find my Biden's, but it has found it, and now we have a good population of both. So we've added 4 species now. I wanted the hackberry emperor. Because that's a butterfly that ought to be here. It's not a beautiful butterfly, but it's one of the species that ought to be part of the fauna of this area. But as its name suggests, it's a specialist on hackberry, and we didn't have any hackberry. Celtis. So I planted hackberry and waited. I had to wait. It was about 4 years before the butterflies actually showed up to use our hackberry. But it's been very successful. I walked by one of my hackberry trees this past June. There were 9 hackberry emperor caterpillars on a single branch. I did not plant goldenrod. It came in on its own, but along with it came many of the things that eat goldenrod, like the brown-hooded owlet, the Arcigera flower moth, the goldenrod leaf miner, the distinct Sparaginothus, the goldenrod gall moth. This is the goldenrod flower moth, and it has not come yet. I don't know why. It should be here, but it's not here yet. This is what its caterpillars look like. So this is anticipation. This is like waiting for the ketchup to come out of the bottle. Every year I go out and I look for the goldenrod flower moth. And one of these years it'll be here, and that'll be a great day. I planted Virginia creeper. Yes, Virginia creeper. It's a good native plant. It has good fall color. It can climb our trees without girdling them, without strangling them, without pulling them down. And it supports particularly big sphinx moths, which are the major portion of cardinal diets. If you want your cardinals, you need sphinx moths. Like the Pandora sphinx, that's its beautiful adult. The lettered sphinx, the hog sphinx, the abbot sphinx, all on Virginia creeper. I wanted to see if I could get the zebra swallowtail at our house. Now I was pushing it with this because we're the northern limit of zebra swallowtails at this part of the world. The closest population is 26 miles south of us. And I just didn't know whether they'd be able to make it that far. They, of course, are specialists on pawpaw. So we planted pawpaw and we waited and we waited. We had to wait 9 years for the zebra swallowtail to show up, but it did. It finally found our pawpaw. In the meantime, we got the pawpaw sphinx. I didn't know there was a pawpaw sphinx, and lots of pawpaws. Wanted the evening primrose moth because it's beautiful. I like beauty like anybody else, but in order to have the evening primrose moth, you need evening primrose. So we planted some evening primrose. The moth comes and it sits with its head stuffed in the flowers during the day. It's very cute. And we planted lots of oaks. Now we planted lots of other plants, but I want to focus on oaks for a while because they're such important plants. This is the Bedford oak in Bedford, New York. Maybe some of you have seen it. People argue about whether it is 400 years old or 500 years old. This is Martha Stewart land, by the way. It's enormous. And a lot of people say, well, you know, I'm not going to plant an oak because I won't live long enough to enjoy it. But you don't have to wait hundreds of years for your oak to start to contribute to the food web on your property. And I know that from experience because I planted my oaks as acorns or as 2-foot bare root whips. So they were either free or they cost $1.50. And right away, they started to attract particularly the moths that run the ecosystems at our house. Like the solitary oak leaf miner, Juvenil's dusky wing, the yellow-shouldered moth, the orange-headed epicalema, the red wash caterpillar, the yellow-vested moth, the orange-tufted oneida, the spiny oak caterpillar, the 2-spotted oak punky, the variable oak leaf caterpillar, the red-humped oak worm, the orange-humped oak worm, the pink-striped oak worm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucolatrix, the white blotch heterocampa, the oblique heterocampa, the red line panapoda, the laugher, and many, many more species. Hundreds of other species of moths have come to the oaks on our property, and they come right away. This is a pin oak that has just popped its head above the leaves here. And here's a crocus geometer standing on the ground eating the leaves of that plant. So your oaks, no matter how small they are, will start to contribute to the food web in your yard. This is what our house looks like today. I'm still sitting in that that room right there. This is just to convince you that, we have a lawn. We're kind of traditional here, but I put a lot of plants back. And I made it a goal 4 years ago to start to count by taking pictures of every species of moth that I could document on our property, just to see how successful we've been in bringing biodiversity back. I'm up to 1,031 species of moths so far, and I'm not finished. And I haven't gotten to the butterflies yet. Now we have 10 acres, but Pennsylvania is 2.4 million acres. So on 240,000th of the landmass, we have 40% of all the moth species that occur in Pennsylvania. And because most of these species are bird food, we have documented 59 species of terrestrial birds that have bred on our 10 acres, not flew by, but bred. In the fall, you probably saw this headline. The World Wildlife Fund says we've lost 2/3 of wildlife from planet Earth since 1970. Very scary headline, but I'm thinking, not at our house. At our house, I guarantee we have increased biodiversity by more than 2/3, and it didn't take that long. So this is the message here is one of hope, really. We can turn these very scary headlines around simply by putting the powerful plants that support the life around us back into our landscapes. Everybody reads these as if it's inevitable. It is not inevitable. But I know what you're thinking. There's an awful lot of people that don't own 10 acres. What about all those small suburban lots? Will it work there? That is a good question. So let's go to Margie and Dan Terpstra's house in Kirkwood, Missouri. They own 0.6 acres, and they're in a traditional suburban neighborhood. Everybody's got the big lawns. The major invasive species in Kirkwood, Missouri is Amur honeysuckle, bush honeysuckle. So the first thing that Margie and Dad did when they got their property is to get rid of their bush honeysuckle. And then they planted a lot of native plants, and they put in a feature they call a bubbler for the birds, and then they sat back and started to count the birds that have used their yard. So on 0.6 acres, 18 times less property than what Cindy and I have, they have recorded 149 bird species, including 35 warbler species. Just to put that in perspective, we've only recorded 8 warbler species at our house. So yes, it works on smaller properties as well. What about urban yards, though? What about really small properties? Well, let's go to Pam Carlson's house in Chicago. And I mean in Chicago. Right on the other side of this wall is one of the runways for O'Hare Airport. Right over here is Kennedy Expressway. And she only has 1/10 of an acre. That's 3 times smaller than the average lot size in North America. Well, Pam did the same thing. She took out her invasive plants, put in 60 species of native plants, a water feature, and then she started to count the birds that have used her yard. And she's up to 117 species that have used her yard, including a woodcock. There's Pam's woodcock. So if you haven't seen a woodcock lately, go to Pam's house in Chicago and you can see her woodcock. Remember, Pam is an isolated island, a tiny little island. There's no connectivity with her yard or any other natural area. So it works in small spaces. But what about city centers? 82% of us live in cities. Do we have to leave those people out? Well, in 2014, I was staring at this plant, butterfly weed, Asclepias tuberosa. People call it butterfly weed. That's the accepted common name. But it reminds me that we have a marketing issue with our native plants. We call them weeds and wonder why people don't plant them. So let's not call it butterfly weed. Let's call it Monarch's Delight. So 2014, I was staring at Monarch's Delight, and the first thing I saw were 2 species of leafcutter bees, megachilid bees. I know they're leafcutter bees because they have pollen on their tummy rather than on their legs. Well, leafcutter bees have very strict requirements, so they can't be in a particular area. Not only do they need pollen and nectar, but they also need soft leaves that they can easily snip the edges out of. And they roll up the piece that they snipped out into a tube and stuff it full of pollen and lay their egg on it. And that is how leafcutter bees reproduce. Well, there was a red bud, very soft leaves, growing right next to Monarch's Delight. And I'm sure that's why leafcutter bees were there. I'm pretty sure that's why bumblebees were there as well. Remember, bumblebees overwinter as queens. So when they come out in the spring, they're alone. They have to do all the work by themselves. So what they need is a lot of forage, a lot of blooming plants early in the season so they can get that colony going without too much work. And if it's not there, then they fail. Well, there were bumblebees there doing well, so I'm pretty sure the redbud had a lot to do with that. And then I saw a monarch. I actually saw two monarchs foraging on Monarch's Delight. Now, this was 2014. If you recall 2013, that was the low point of the monarch population in the East. I had gone the entire year without seeing a single monarch. It was very depressing. And this was June of 2014. We usually don't get monarchs this far north by June, so I was encouraged. It looked like maybe the monarchs weren't going to disappear after all. Why were they there? Well, they had Monarch's Delight, but they also had another species of milkweed. I think it's purple milkweed. So they had forage, they had some nectar to drink from, but they also had their host plant, a milkweed, so that they could reproduce. It's all they need. Do you know where I was? I was on the High Line in the middle of Manhattan. If you've ever been to the High Line, it is that's the nature there. It's a strip of plants along an abandoned elevated railroad that was converted to a tourist destination. It's about a mile long, I guess. It's 30 feet above the taxis, right in the middle of the bustle and hustle of Manhattan. And it's a very successful tourist destination. Millions of people go to the High Line every year. So there's always somebody around. And yet the living things I saw didn't care. They're there anyway. This is Rick Dark. He was always after me to go to the High Line and appreciate the beautiful plantings. And, you know, I'm not much of a city boy. So I dragged my feet. And also, if I go and see beautiful plantings, but nothing's using those plants, that's actually depressing to me. I want to see them become part of the local ecosystem. And I had no hope at all of finding living things along the High Line in the middle of Manhattan. Well, anyway, he finally got me there. We was only up there 20 minutes, and I saw all the things I just showed you. Somebody just finished a survey of the native bees using the High Line. They're up to 30 species. So I was completely wrong. The High Line shows that thoughtful native plantings, and it's not 100% native, can bring life back to the middle of Manhattan. And if we can do that there with native plants, we can do that anywhere. But there are four things we need to think about if we're going to succeed. And one of them is we have to shrink the area that we have in lawn in the United States. We've got over 40 million acres of lawn nationwide. That's bigger than an area that's bigger than New England in size. And of course, lawn is not a functioning ecosystem. It's a status symbol. And we have to manicure it to show that we're good citizens. But let's cut the area of lawn in half. We can still have our status symbol, still be manicured, but we're going to have smaller areas of it. And we're going to put in the plants that support the life around us. And if we cut the area of lawn in half, that'll give us 20 million acres to use for conservation. And if we do this at home, we can create a new national park that I'm calling Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, plus the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Add up all those parks, still less than 20 million acres. So Homegrown National Park will be the biggest park in the country. And there's immediate benefits to creating a park where you live. You get to develop a personal relationship with some part of nature just by walking outside. You can do it at your own time, at your own pace, avoiding crowds. You know, if you go to a real national park, there are millions of people there. It's free. There's no admission charge. It's never closed, no matter what pandemic's out there. You can always go outside. No travel hassles. You get to experience the natural world alone. And I think that's essential to developing that personal relationship with that natural world. It's particularly important for our poor kids. Richard Lewis says our kids are suffering from nature deficit disorder. So we try, we get a bus, we put 30 kids on a bus with a teacher and they drive for an hour to a natural place and then they get out and walk around for an hour. Teacher tells them not to touch anything. Then they get back in the bus and they drive back, and that's their experience with the natural world. I'm sure it's better than nothing, but it's really an experience with 30 other kids and a teacher telling them not to touch anything. We've got to get our kids outside at home. Let them go out alone. No parental supervision. Let them work it out. Let them take risks. Most of them will make it back alive, but they will be able to establish that relationship, which is so important because our kids are the future stewards of the planet. And if they don't have a personal relationship with what they're supposed to be stewarding, they're going to be lousy stewards. And maybe they will learn to hunt lizards. I'm learning this from my own granddaughter, Zoe, who lives in Hawaii. on a very small patch of nature, and it's not all that natural. It's lawn and a hedge. But there are anole lizards there. And Zoe sent me this picture to show me how to hunt anole lizards in Hawaii. You get on the ground and you disguise yourself with leaves and sticks so that the lizards can't see you coming. Then you crawl slowly toward the lizard. No smiling. This is very, very serious. You can wear your best dress. That's okay. But you sneak up on the lizard, you catch the lizard, you put it in an aquarium, and you've got that personal relationship with the lizard. Now, I don't think Zoe's going to be doing this the rest of her life. I don't think. But I guarantee she will remember hunting lizards in Hawaii the rest of her life. She's got that personal relationship. And I also guarantee she's going to be a good steward of the planet because of it. If you want your kids or your grandkids to do more than hunt lizards, get this book, Nature Play at Home by Nancy Stranisti. There are dozens of examples of how to expose our kids to nature right at home. And if you want to join Homegrown National Park, you at Cartmel can do it. Crosslands, anybody can do it. You go to this website, homegrownnationalpark.org, and you put in the data where you live and the amount of area that you would consider preserved, or that you plan to add natives to, or that you already have added natives to. And then you can light up your little piece of, it would be Chester County. And you get to see who else has lit up Chester County. And you can have competitions. The object is to light up the whole country here. This is our attempt at a social media viral campaign to get people to take the ownership of the earth seriously and become good stewards. Okay, we're going to shrink the lawn. And we're going to put in plants in half the area that we take out of lawn. But which plants should we add to our yard? Well, some of them have to be what I'm calling keystone species. Remember what a keystone is. You've got the Roman arch. The keystone is the stone right in the top of the arch, right in the center. And if you take that out, the arch collapses. Well, keystone plants act that way. They are essential to our food web, so essential that if we take them out of the food web collapses. It turns out that just 5% of our native plants are making about 75% of the caterpillar food that drives the food webs that supports everything else. 14% of our native plants are supporting 90% of those caterpillars, which means 85% of our native plants are contributing, but not all that much. They can't stand on their own. So keystone plants are like the 2x4s in a house. When you're building a house, you can't start with the wallpaper. You have to have those supports that support everything else, and that's what keystone plants are. So the question no longer is simply, are natives better than non-natives at supporting the life around us? On average, they certainly are. But the question really is, do we want the most powerful ecological plants in our yards to support the most life possible, or benign plants that aren't doing much, or even worse, those invasive plants from Asia? Things like burning bush and calorie pear, among the worst, autumn olive, porcelain berry, that escape and biologically pollute all the land around us, ecologically castrate it. I get an email once or twice a year from people who say, don't you know that ginkgos, ginkgo biloba from Asia, actually grew in North America 7 million years ago? That makes them native. That means we can plant them and everything will be great. Yes, I do know that ginkgos grew in North America 7 million years ago. We can argue about whether that makes them native today, but I'm not going to have that argument because that's not the metric anymore. The metric is, how productive are they? What are they supporting? I don't care if ginkgos grew on the moon 7 million years ago. They essentially support 0 species of caterpillars. There are 2 rare records on ginkgo, but you never ever found them. I've never found them. So if you go out and check your ginkgo, it will have nothing on it. And that's the problem. You're not going to support your local food web by planting ginkgos. What will support your local food web? Well, nothing does it better than oaks. In 84% of the counties of North America, oaks support more life than any other plant genus. 557 species of caterpillars in the mid-Atlantic states. And remember, those caterpillars are bird food. They support over 900 species of caterpillars nationwide. No other plant genus comes close to that. And this is what those keystone oaks are doing in my yard. Remember, I've taken pictures of 1,031 moss species so far. Out of that 1,031 moss species, 907 have known host plants. There's more than 100 I don't know what they're eating. So out of the 907, 267 species use oaks. We have 69 genera of native woody plants on our property, but only one of them is Quercus, the oaks. And we have hundreds of genera of herbaceous plants. So oaks represent less than 1.5% of our woody plant diversity and way less than 1% of our total plant diversity. But they're supporting almost 30% of our moth species diversity. Imagine what would happen if we took oaks out of our landscape. What would happen to the diversity of insects and the birds that are using them? If you want to know what the keystone plants are where you live, go to the National Wildlife Federation Native Plant Finder, put in your zip code, and the ranked list of both woody and herbaceous plants for your county. So yours is going to be just like mine, Chester County, will pop up. Oaks are going to be number 1, but notice I say native oaks. Native cherries are going to be number 2. Native willows. I say native because if you go to the nursery and you say, I want to buy a cherry, they're going to sell you an Asian flowering cherry. They probably don't even have black cherry, which is the most important one around here. If you say, I want to buy a willow, they'll sell you a weeping willow from Turkey. If you want to buy a birch, they'll sell you a European birch. Or I want to buy a maple, they'll sell you a Japanese maple. You've got to specify that you want a native member of these genera, because if you plant non-native members, you're reducing caterpillar use by 65%. These are the top herbaceous genera in our area. Goldenrod's very high. The several genera of asters are very high. Particularly our perennial sunflower is very high. Not only in making caterpillars, but also supporting the specialist bees that can only reproduce on their pollen. There are at least 40 species of bees that can only reproduce on the pollen of those 3 genera. And if we don't have them in our yards, that's 40 species gone right there. Okay, we're going to reduce the lawn. We're going to put in keystone plants, attract a lot of insects, particularly moths, to our yards, and then we'll kill them with our security light, which of course is not the goal. There's a lot of research coming out now, particularly from Europe, that suggests very strongly that light pollution at night is a major cause of insect declines. When the lights attract the insects, they kill them by exhaustion, by collisions, by incineration, dehydration. The bat comes and eats the moths. Bright lights blind a lot of our nocturnal insects. Who knew? And it keeps them from doing what they should be doing. Well, to me, this is actually really good news. If light pollution at night, if those security lights we have on, or just that light over our front porch, is a major cause of insect declines, it's also the easiest one to turn around. All we have to do is flick a switch, turn it out. I know what you're going to say. I can't turn it out because the bad man will come. Well, then put a motion sensor on it, so it only turns on when the bad man does come. And the first thing you're gonna realize is the bad man doesn't come very often. And if you don't want to do that, take out the white bulb from your night light and put in a yellow bulb. And a yellow LED bulb is the most effective, because yellow wavelengths don't attract very many insects. They're not attractive to nocturnal insects. If we switched out our night lights from white lights to yellow LED lights overnight in the summertime, we would save billions of insects. And nationwide, we'd probably save billions of dollars too, because they're much more energy efficient than our other bulbs. The fourth thing we need to do is to landscape in a way that allows caterpillars to complete their development. What do I mean by that? Well, in Chester County, oaks support 511 species of caterpillars. A few of them, like the polyphemus moth caterpillar, completes their development on the oak tree. The caterpillar eats the leaves, then it spins a cocoon and hangs from the branches, and then it emerges as an adult, and it does it all over again. I wish everything did that, but most species don't. 480 of those 511 species, 94%, drop from the ground when they finish growing as caterpillars and wiggle their way underneath the ground and pupate underground. Or they spin a cocoon in the leaf litter that's under the tree. And that's the problem. We have no leaf litter under the tree, and we mow and compact the soil so that it's way too hard for those caterpillars to get underground, which creates what we call an ecological trap. We're calling in the moths to lay their eggs, the caterpillars develop, and then they fall down and die. And the next generation is even smaller, and then the next generation after that is gone altogether. So I'm convinced that the typical way we landscape under our trees is another major cause of insect declines. And of course, the cement landscape is even less of an option. I'm not trying to discourage the use of cement or of trees in cities, but I am trying to discourage the use of cement as a default landscape. That's just laziness. And we know it destroys our watersheds. And we know that cement is one of the major emitters of carbon dioxide, a greenhouse gas. So there's lots of good reasons to end that practice. This is what we typically do. We have a tree in the middle of a big lawn. Nobody's measured how well caterpillars survive in a situation like this, but I guarantee they survive in a situation like this better. This is a shot from Mount Cuba. Mount Cuba's doing it right, folks. I mean, here's a tree. It could be an understory tree like a dogwood over here, a native azalea, ferns, and then ground cover. The caterpillars drop to the ground and they survive. They can easily wiggle themselves underground because the ground's not compacted. They can spin a cocoon in the leaves that are there. Nobody's going to mow them. Nobody's going to squish them by stepping on them. It becomes a safe site. This is where you can do your spring ephemeral gardening. Another shot from Mount Cuba, but it's a good thing to strive for. And this is the way we reduce the area around our trees. Put beds around those trees. And if you don't want to invest in making a beautiful bed like this, then just put in a ground cover around the tree, like wild ginger or mayapple or foam flower, and mix them up. So you have so many plants you can't even see the ground. Ferns are great ground covers. This is a hotel in Athens, Georgia. These are red maples. Anything developing on these red maples can drop down in here into safe sites and actually make it, even though it's the middle of a city. There's more research from another grad student, Desiree Narango, who has demonstrated from her research on chickadees in Washington, D.C., that there is room for compromise in our plant choices. What Desiree did was look at how landscapes that were dominated by native plants, and we're talking about homeowners' yards, how landscapes dominated by native plants sustained chickadee populations compared to landscapes dominated by introduced plants, typically those Asian ornamentals. And it was a big study. She did it actually over 5 years. First thing she found is that those landscapes that were dominated by non-native plants produced 75% fewer caterpillars. So they reduced the amount of caterpillar food by 75, or the amount of bird food by 75%. They were 60% less likely to have breeding chickadees at all. So there were nest boxes up, but the chickadees would come and look around and say, there's not enough food here. We're not even going to try to reproduce. If they did build a nest, they laid 1.5 fewer eggs in that nest. Those nests were 29% less likely to survive at all. If they did survive, they produced 1.2 fewer fledglings, and it took them 1.5 days longer to do that. If you put all that together in a population growth model, this is what you get as a function of the percentage of non-native plant biomass in your yard, from no non-native plants to 100%. The dotted line is replacement rate. This is how fast the population has to make babies to replace the adults that die every year. If you reproduce at this rate, you have a sustainable population. It's not growing, but it's not shrinking either. If you make more babies than adults die, you have a growing population. But if you make fewer babies than adults die, you have a shrinking population. So anything below this line is a shrinking population. Right here is where those lines overlap, which suggests we can have up to 30% of our woody plant biomass non-native in our yards without destroying the local food web, so our birds can still reproduce. In other words, if 70% of our woody plant biomass is native, it'll be okay. And what I like about this is the area of compromise. You can have your crepe myrtle, you can have your boxwood, you can have anything that's not invasive. And as long as it doesn't dominate the landscape so that you're down in this area here, you can sustain both chickadees, titmice, all the other birds, because there will be enough food. And that's good news to me, because if my message was you can't have any non-natives, very few people would listen, because we love our non-natives. It's not the presence of non-native plants that destroys food webs. It's the absence of native plants. If we add these, we can tolerate these. Can we use natives in formal designs? Of course we can. This is a garden from North Carolina, and they're in the process of switching it from all non-native to all native. They got their Joe Pye in there. Notice I didn't say Joe Pye weed. It's not a weed. And when they complete the transition, they're going to send me a picture. Formality is a function of the design. It's not a function of the plants in the design. Our native plants are used in formal gardens in Europe all the time. And I guess that's okay because they're non-native plants there. Can we get a pollinator garden into a traditional suburban yard like this without offending anybody? Of course we can. Just put a fence around it. It formalizes it. It's beautiful. It's supporting a number of species of native bees. It's not very big, but if everybody did it, it would still supply a lot of functional pollen and nectar for those bees. Here's a bigger one. This is a Drew Latham design. Imagine the amount of life that is here versus the amount of life that is here. A lot, none. Can municipalities help us live with nature? Of course they can. And they're doing it more and more. Minnesota has a cost sharing program that pays people, homeowners, to reduce the area of lawn and replace it with appropriate Minnesota prairie plants. Pennsylvania has a similar program, just started last year. I just learned about it yesterday. So very, very successful. Florida is paying, there's an island off Florida that's paying residents to allow the burrowing owl, a listed species, to burrow in their front yards. This is the way the Endangered Species Act should have been written, with carrots rather than sticks. Rather than fining somebody if an endangered species comes to their yard, you pay them. Pay them to be good stewards of that species. Everybody would want an endangered species. Missouri, Fayetteville, Arkansas have a bounty on calorie pears. You take out a calorie pear and they will give you a free tree replacement. Even public utilities are getting into the act. They're giving people $100 coupons in San Antonio to replace non-native water-thirsty plants with appropriate water-efficient plants. And of course, the big lawn replacement programs in the far west, particularly California, get up to $2 per square foot rebate by taking out that thirsty lawn where there's not enough rain and replacing it with xeric plantings. I think we've made 3 missteps in the early years of conservation. It's not that we don't like nature. It's not even that we don't think it's important, but we don't think it's essential. That's the misstep. And that means when resources are short, when push comes to shove, nature loses. I went to the Cincinnati Zoo before the virus broke out. There was this wall-sized poster there, which to me epitomizes what our society thinks of conservation. It says, "Save wildlife for future generations." You know, that was Teddy Roosevelt's argument for creating national parks. We need to create these national parks so that future generations can enjoy the splendor of nature. And I totally agree with that. But it suggests nature's there just for our entertainment. No wonder we don't think it's essential. Entertainment's not essential, let's face it. But nature's much more than that. We need to save nature, not so that we can be entertained, but so that we have future generations. It's a little bit more urgent. We've also assumed that humans and nature cannot coexist. Now, we talked about this, but by restricting conservation just to areas where there's not a lot of humans, we're going to fail because those areas are not big enough or connected enough to sustain the species that run our ecosystems. David Quammen has this excellent analogy between a Persian rug and an ecosystem. This is a functioning Persian rug. That is not 71 Persian rugs. That's 71 rug fragments, and this is exactly what we've done to our ecosystems. None of these fragments are acting like a Persian rug, and none of our habitat fragments are acting like a connected ecosystem. The UN designates biosphere reserves as places of ecological significance, but I hate that terminology because it suggests they're places on planet Earth without any ecological significance. Not so. Every square inch of the planet has ecological significance, including our yards, including our campuses, including our roadsides, including our corporate landscapes. So we need to stitch our rug back together again, stitch our ecosystems back together again by putting in the plants where we work, live, play, and to a lesser extent where we farm right now. We're not just creating biological corridors to allow plants and animals to move back and forth between viable habitats. We're going to create viable habitats using those keystone plants right where we live right now. In other words, we're going to start to share our spaces with nature. Our third misstep was to assume or leave Earth stewardship to just a few specialists, a few biologists, a few conservation ecologists. We didn't see it as an inherent responsibility of every human being on the planet. But I don't know why, because every human being on the planet depends entirely on the quality of Earth's ecosystems. So why wouldn't everybody bear the responsibility of good Earth stewardship? Stan Rushworth, a Cherokee elder, once said that the Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. You're not born with these mindsets, you're taught them. We're really good at teaching this one. We have been terrible at teaching not just our kids, but us, that we all have obligations towards planet Earth. It doesn't mean you have to save biodiversity for a living, but you can save it where you live. That's the important point here. And it empowers each one of us. So many of us feel powerless now because the Earth's problems are so huge. It really looks like a single person can't make a difference, but you can. Get permission to plant that oak tree. Put a bed around the trees that exist. Get rid of the invasive plants on the campus. Shrink the lawn. A single person can contribute to all of that, and you can watch nature come back to Cartmel, come back to Crosslands. That makes each one of you an important cog in the future wheel of conservation. And it also shrinks the problem down to something that's manageable for each one of us. Don't think about the entire planet's problems. Just worry about the piece of the earth that you can manipulate. At this stage in our lives, it's where we're living. And for people who don't own property, you can volunteer. Help somebody who does own property. Help a land conservancy. Help a park or a preserve near you. They're all understaffed, underfunded. They'll love you. So as property owners or as volunteers, each one of us has the power, and we certainly have the responsibility to fix dead landscapes like this. Whether or not we do so is going to determine nature's fate and ultimately our own fate. Now, I've convinced my grandchildren that you are nature's best hope. I hope I've convinced you as well. Thanks for listening.
Doug, what an educational program for our community. It was great.
Thank you.
And I'm sure that most of us are glad or hoping the snow will go this week and we can get out and start getting rid of non-native plants and planting the native ones. The one thing that probably a large percentage of us will not be doing is hunting lizards like your granddaughter.
Probably not, yeah.
Okay, let's go to some questions. Let's see what we have here.
Should we play?
All right, we've got one hand raised. Dick Hayden.
Go ahead.
Yeah. What can you tell us about the spotted lanternfly?
I can tell you that I walked up my driveway today and there were 4 egg masses of the spotted lanternfly on one branch of my pine tree, and I've got to go get them. It's just another one of the invasive insects. So I talk about us needing insects, but not insects from other continents that are here without their natural enemies. So the spotted lanternfly, the gypsy moth, the hemlock woolly adelgid, the emerald ash borer, all of them cause tremendous problems. It is so hard to get rid of them once they're here. So the key is to stop bringing them in, but of course we have. The spotted lanternfly came here on ornamental rocks from China, because we absolutely need ornamental rocks from China. We don't have any ornamental rocks in North America. The egg masses were laid on the rock and nobody saw them. Nobody was looking for them, and that's how it got here. And now it's just another huge problem. They have sucking mouth parts, and they love Alanthus, by the way. That's where they develop most. So if you have Alanthus around, it's a good reason to get rid of it. That's another non-native plant. But they also do really well on fruits. So things like grapes and apples. They're devastating those industries because fruits are not protected very well. They're sweet, so they can eat them without any problem. So what do? Our options are few. We look to biocontrol, trying to find a parasitoid or a disease that we could introduce that would control them, but that takes a long, long time and often doesn't work at all. Somebody noticed next to milkweed plantings, there were a pile of dead lanternflies that had fed on the milkweed and died. So if that works, I mean, if you have a lanternfly problem, and pretty much everybody does now, plant a lot of milkweeds. It'll help the monarchs and maybe keep those populations under control.
Thank you.
Great, thank you.
Steve, do you see the chat questions? Because I do not.
Well, I think I'm next. Doug, I want
Yes.
to tell you that that was the best environmental talk I have ever heard. I could have listened to you all day. Thank you.
Well, thank you.
We have no chat questions at this point,
Okay.
but we have some hands raised.
May I ask Doug, to what extent would your recommendations change in the light of climate change?
That's a good question. What I talk about is a serious problem, even if we had no climate change. Of course, I wish we had no climate change, but we have destroyed viable habitats regardless of climate change. And right now, climate change is very, very serious, and a lot of people are talking about it. The only problem I have is that they think that's the only environmental problem we have. And unfortunately, it's not. We have to address this one at the same time. Some people are suggesting, well, the planet's going to gradually warm, therefore we should plant plants from the south up north. That's called assisted migration. But boy, what happened in the last 2 weeks is exactly why we should not do that. Because every once in a while, because of climate change, we're getting these huge polar vortices, a vortex. The cold air comes rushing way far south than it used to, because the jet streams that control those winter surges are now much weaker than they used to be because of climate change. So it's diving south. You know, the one that hit Texas went all the way to Mexico. And any plant you would move farther north than it can handle would die from that. So what we need, what climate change really is increased variability. The climate is going crazy, as opposed, on average, it's getting warmer by a few degrees. But what's really happening locally is heavier rains, colder weather, hotter weather, drier weather, all of it happening in real fast sequences, which makes it very hard both on the plants and the animals that use those plants. So what we need is the most genetic variability in our animal and plant life possible, because that's what's going to allow those animals and plants to adapt to climate change. The real challenge is, of course, having them adapt fast enough, because climate change is coming on really fast. But another thing is, if we planted those 40 million acres of lawn and a lot more plants, all those plants are built out of carbon and pumping carbon into the atmosphere. The very worst plant that's out there in terms of fighting climate change is lawn, because its roots are tiny. We mow it, so it's not sequestering anything. Almost any plant is going to do a better job. So the more plants we put in the landscape, the less carbon is in the atmosphere. We're not going to remove it all, but it's going to help a lot by putting plants back on the planet.
Okay, I do see one chat question from Sue Wells. And the question is, can we purchase your video talk to take to family and friends? Do you have that available or not?
No, I don't. People, did you say you're recording this?
Yes, we are recording it.
Well, you've got it then.
Okay. All right.
I don't have it and I don't sell it, but a lot of people do tape it, and they're all over the YouTubes and things. But so yes, you're welcome to take it anywhere you want.
Okay, thanks, Doug. Steve, do you have any other questions? Hands up.
Yeah, Dale, Kendall.
Hi, Doug. It's nice to see you.
Hey, Dale, how are you?
I'm good. It was a wonderful program. Thank you
Thanks.
so much. I do have a question. I think you said that the chickadees don't go, the Carolina chickadee doesn't go very far for its caterpillars.
Yeah,
But
about
they
50
need-
meters from the nest.
But how do they get 9,000 caterpillars to feed their young?
Because the landscape around them has 9,000 caterpillars. Remember, on oak trees, they support 557 species of caterpillars. That's why it's so important to have those really powerful plants around, so that they can get all the food they need. And that's what Desiree's research in Washington, D.C. showed. When people don't plant those plants that have enough caterpillars, the chickadees fail in reproduction. That's a good question.
Thanks, Doug.
Jennifer, do you have another question?
No, sorry, I didn't take my hand down.
Okay.
Take mine down too.
I see another chat question, and this is from Bert Rothenberger. The talk is on the homegrownnationalpark.org on the Tallamy Hub tab.
Okay, I I didn't realize it was up there.
Well, that's
There you go.
according to
Good.
Bert.
Good. Okay.
Any other questions?
I see no hands raised.
Well, Doug, we just cannot thank you enough for that wonderful, wonderful talk. So educational. And I think all 4 of the Kendall at Longwood communities are going to be out working.
But
as
you're
soon
a
as
very
the snow
appreciative
goes.
audience, so
Yeah.
thank you.
Yes, we do. Yes. Thanks, Doug, very much. And thank
All
you
right.
all for participating with us today. We had over 100 people at one point. So
Wow.
thank you.
All right, go
Thanks
have a
to
glass of wine
Cardinal
now.
for doing this.
Thank you, Doug.
All right, take
Thanks,
care.
Doug.